Next educational video. I'm going to show you 3 examples on partial differentiation, which is the process of finding partial derivatives. First, let's recall the notations. You can either find partial derivative with respect to x, denoted by f subscript x, or df dx, or with respect to y, denoted by f subscript y. Anytime when we are doing the differentiation, we hold one of the variables a constant. So it's important to know which one is a constant. In example 1, we have a function given by x to the power of 3 plus cosine y. When we find f of x, cosine y is just a constant. So when we do the differentiation for cosine y, we will get a 0. As for x to the power of 3, we will get 3x squared. So the answer for f of x is just 3x squared. On the other hand, if you find the partial derivative with respect to y, then x power 3 becomes the constant. And differentiation of cosine y with respect to y gives minus sine y. Let's look at an example involving products. This time the function g is the product of x to the power of 3 and cosine y. First we differentiate x, we differentiate g with respect to x. Cosine y becomes a constant. So when you differentiate a constant multiple of a function, what you get is the same constant multiple multiplied by the derivative of the constant. And this is what exactly we are doing here. We keep the constant cosine y and we differentiate x to the power of 3 with respect to x. That will give us 3x squared. Let's try differentiating g with respect to y. This time round, x to the power of 3 becomes the constant. Differentiating cosine y will give us negative sine y. Finally, an example involving the product rule. Again, we have a product of 2 functions, 2y to the power of 3 and cosine xy. First, we differentiate h with respect to x. Inspecting the terms carefully, 2y squared is actually a constant with respect to x. So in this case, differentiation of h is simply 2y cubed multiplied by the derivative of cosine xy. But cosine xy with respect to x makes y a constant. And we also recall the derivative of cosine of a function from the single variable calculus, which is minus g prime dot psi g. In this case, g is x times y. So the differentiation of xy with respect to x is y. So this is our g prime. And followed by psi of the function g, which is xy. So h subscript x is minus 2y to the power of 4 multiplied by sine of xy. Now let's differentiate h partially with respect to y. This time, we have more work to do. And that's because both 2y cubed and cosine xy are functions of y. So we are differentiating a product of 2 functions of y with respect to y. So we need the so-called product rule. For single variable calculus, product rule says the derivative of the product of 2 functions uv is given by u prime v plus v prime u. So it's understood here that little u is 2y cubed and little v is cosine xy. So if first differentiate 2y cubed respect to y, that will give us 6y squared. So 6y squared is our u prime. Multiplied by v, which is cosine xy. Then followed by differentiation of v, which is the differentiation of cosine xy with respect to y. So that will give us minus x sine xy. And then multiplied by v, which is 2y cubed. We can simplify this expression to get 6y squared cosine xy and then minus 2xy cubed sine xy. Finally, we end the video with a function in 3 variables. Partial differentiation is done in a similar fashion. Each time we hold 2 variables a constant and differentiate the function with respect to only 1 variable. Take this example f given by this expression. When you differentiate f with respect to x, y squared z is a constant and differentiating 2x gives us 2. With respect to y, 2x becomes a constant and y squared z will give us 2z1. And finally, with respect to z, again 2x will be a constant and differentiating y squared z with respect to z will give us y squared. So partial differentiation can be done for a function of any number of variables.